Hey guys, Mr. Martin back here again with the second video in our proofs. Hey, we talked a lot about the properties and getting ready for setting up geometric proofs, and we are ready to actually do geometric proofs now. Alright, let's get going. This first proof is from an example that was in the previous section under algebraic proofs, but I thought it was kind of misplaced, so I'm going to bring it over to the section on geometric proofs. Okay? The first thing you want to notice is they gave us a diagram along with our given information. Right? So they've got this picture here along with the given information. Okay? So we know the very first statement of the proof is always the given information. Okay? So one thing we want to do is look at the diagram and see what the given information does in terms of the diagram. So we can see on angle 1, they've got one arc there. Let's make that a little bit more obvious. Okay? They've got an arc there, and they've got an arc there. Okay, so those two angles have the same measure, or we can say those two angles are congruent, right? Alright, so now what we're trying to prove is that we're trying to prove that angle EBA, which is angle EBA, so that angle is congruent to angle DBC. Okay? So that's the two angles that we're trying to prove are congruent to each other. What I immediately notice in this is that these two angles share that piece in the middle. They share angle 2. So I'm thinking that that might have something to do with proving that those two bigger angles are congruent to each other. So I'm just making note of that. Not really sure if that's going to mean anything to me or not, but I'm going to take note of it. And then let's look at the statements that they gave us, okay? The first statement they gave us is that angle EBA is equal to the measure of angle 3 plus the measure of angle 2. So that first big angle that they gave us, EBA, okay, they tell us that that's equal to the measure of angle 2 plus the measure of angle 3. Now, how do we know that when we have two little angles that we can add them together and make the big angle? Well, if you remember, that's called the angle addition postulate, right? Okay, so I'm going to put the angle addition postulate as the reason for statement number 2. Okay? Alright, then they go on to say that the measure of angle EBA now is equal to the measure of angle 1 plus the measure of angle 2. So they changed something on the previous statement. Okay, if you notice, they said it used to be EBA was equal to 3 plus 2, or the measure of angle 3 plus the measure of angle 2. Now it's equal to 1 plus 2, or the measure of angle 1 plus the measure of angle 2. So why did they make that change? Well, remember before they told us that 1 was equal to 3. So what they took out 3 and they put 1 in its place. So what lets us take out something and put something equal in its place? That, of course, is the substitution property. Okay, so we've got now two statements, both equal to the measure of angle EBA. Okay? The first one was from the angle addition postulate, and the second one, since we knew the measure of angle 3 was equal to the measure of angle 1, we took out the measure of angle 3 and we put in the measure of angle 1. Okay? Alright, let's go on to the next statement. Now they're telling us that the measure of angle 1 plus the measure of angle 2, so the measure of angle 1 plus the measure of angle 2, okay, is equal to DBC. And again, we've got two smaller angles equal to the bigger angle. we again know that that is the angle addition postulate, right? Now this is what we talked about in class. If you get tired of writing out angle addition postulate, you can write something like the angle add post, P-O-S-T. Okay? But for right now, I'm just going to go ahead and write each one of them out. Okay? Alright, last statement. One more to go. So now somehow they jump to the measure of angle EBA equals the measure of DBC, the measure of angle DBC. How do they make that jump? Well, that involves looking at these two statements here. If you notice, both of those statements have the measure of angle 1 plus the measure of angle 2 in them. So we really have the same thing. Okay, it's measure of angle 1 plus the measure of angle 2 is in there twice. Okay? If you remember, we had one property that talked about when A equals B and B equals C, then we could make the assumption, or sorry, make the conclusion. We're not assuming because this is a property, right? We're making the conclusion that A must equal to C. Okay? So in this case, we've got the measure of angle EBA equal to the measure of angle 1 plus the measure of angle 2. And then we've got the measure of angle 1 plus the measure of angle 2 equal to the measure of angle DBC. So we've got that common event in the middle here. And we can take that out and say that these two must be equal to each other. Okay? So this is from the, and remember that is called the that's right, that's called the transitive property. There you go. We tackled the first proof. Okay? We, of course, remember, we start with the given statement. Then we move on to the information that we know is true based on what was given or based on what the diagram shows us. All right? Let's tackle one more. I know we are looking like it's going to be a long video, but we're going to make this next one really short. Okay? Alright, this time we're given a segment. Okay, we're given that segment, the measure of segment AC is equal to AB plus AB. Now it seems a little interesting. Okay? What they're telling us that 2 of segment AB makes up all of that segment. Interesting, huh? So let's see what we can do with this. Based on that, they want us to prove that AB, again, AB, they want us to prove that AB, the yellow one, is equal to the purple one. Okay? So they're telling us that the AC, the red one, is equal to AB plus AB, or in other words, 2 ABs. Okay? Alright, so let's take a look at what they've given us. Of course, first statement is always the given information. Okay? The second statement is something that we know to be true because the segment addition postulate. We know that 2 little segments added together make the big segment. That's nothing new. Okay? So now let's figure out how do they transition from the first 2 statements to the third statement. Again, it requires us to look at those two statements. Again, we notice we've got the same thing equal to two different things. Okay? We have AC is equal to AB plus AB on the first one, and then AB plus BC equals AC on the second one, or we could rewrite that as AC equals AB plus BC, either way. And we've got the two ACs here equal to two different things. So we can set those two different things equal to each other. That's that same one that said if A equals B and B equals C, then A equals C. We're now starting to see the transitive property in action now. Okay, so anytime you have the same thing, AC, equal to two different things, AB plus AB and AB plus BC, then you know those two different things must be equal to each other. Alright, last statement. How do we get to the last statement? How do we say that AB must equal BC? If you notice in the previous statement, they both had what in them? Look at the left side and the right side of that previous line. They both have a AB in it, don't they? So why don't we go ahead and subtract that from both sides? Let's take away an AB from both sides. So that goes away, and that goes away. And what's it leave us? Well, it leaves us the AB and the BC. So we say that was done from the subtraction property of equality. You can just put the subtraction property. I'm okay with that. Okay? Alright. So there you go, guys. We've done our first two proofs. We've actually proved something in geometry now. So just to recap really quickly, we always start with the given information, right? Always start with the given information. And we look at the given information along with the picture and start to think about what we know has to be true because of either the way the picture is drawn, the facts that we know about segments or angles or anything that has to do with what's going on in the picture. And we put all that knowledge together to deduce what they're asking us to prove. The last statement will always be what they asked us to prove. Okay? First statement is always what they gave us. Last statement is always what they asked us to prove. Alright, get those into your notes, you guys. Take a real good close look at your notes after you've watched the video and make sure you understand what's going on. Okay, there is a lot of proofs that we're going to tackle tomorrow in class. We'll take them one by one. Hang in there and we'll get through this. Alright, we'll see you guys in class tomorrow.